my computer and then send it to you. How about that?
Okay. Also, I'm struggling a little bit with dosing in intervals. So
Okay.
if you can explain that, oh, like if we come to that
Okay.
conclusion too.
Sounds good.
Okay. Fill in the graph below drug Y during the constant infusion before and after the addition of drugs Z, which displaced drug Y from the plasma proteins. Dose 150 milligrams under the curve IV is 185 milligrams per liter times the hour. FE FE is the bioavailability. Wait, is that the
No, Fe I gave you a hint on because you didn't know. I don't think you know what that is. It's the fraction excreted unchanged in the urine. So Fe tells you what percentage of the clearance is due to the kidneys, and if it's due to the kidneys, then it's not due to the liver, and vice versa. So if none of the drug is showing up in the urine and unchanged, that means none of it's been cleared by the kidneys and it's all been metabolized into something new.
okay?
So basically, Fe equals 0 means that it's all hepatically cleared.
Okay. And we got that recorded so I can write that down when
Mm-hmm. It's in your hints and your announcements too. I think I put it in
I
there.
I seen it, but like it's just
Yeah.
I've been trying to worry about this exam tomorrow too. And it's,
What do you have tomorrow?
drug drug evaluate what is it? Literature or is it
Oh, okay. And safety
pharmacy
one?
research? I, honestly, I combine everything together that I forget what the classes are called sometimes. I just know that it's due and I gotta study it. The only class that I know the name of is pharma pharmacokinetics and pharmacodynamics because it's cool to say.
It
And
is cool to say.
um and I like the science side of it. I'm just really disappointed in myself that I don't understand it. So yeah.
Well, it does take time, but I'm
Okay.
sure you're capable.
So the FE is the time that it clears by the time I'm just summarizing it. By the time it gets to the kidneys, you said fraction.
It's the fraction that it's excreted in the urine as unchanged drug. So, in other
Okay.
words, it's the percentage of drug that shows up in your urine as the parent drug, which means that's the stuff that's renally cleared. So Fe equals 0 tells you that it's hepatically cleared. It's cleared by the liver because they're all the drug is changed into something new. So basically, that means it's hepatically cleared, which, considering we're doing hepatic clearance, probably makes sense, right?
Connections. Yes. Okay. So okay, I have it.
So Fe is 0. We have drug Y that's being given as a constant infusion. We also know about the drug that if we give a 150 milligram dose of it IV, we're going to get an area under the curve of 185. Well, does this help us at all? So we also know it's totally cleared by the liver. It's 88% bound to plasma proteins and has a half-life of 30 hours. We also know that this drug Z displaces Y from its plasma protein. So, um, I'm gonna
I was gonna say, is there a way? Do you want to share your screen?
I'm gonna share and do a whiteboard. How about that? Can I do
Okay,
that? Yes.
that's fine. And when it's bounded, I'm sorry, when it's bound 88%, so that means that 12% is unbounded.
Correct.
Bound
That's
spiral.
exactly what it means.
Okay. I'm getting
You know it. That's good. See, it's not that you don't know anything.
there.
All right. So I'm going to start working on this problem. So
Okay.
we want to know what happens when the fraction unbound increases, right? That's really what's happened when it's been displaced.
Okay.
Are you good with that?
Probably not, but I understand what you mean.
If you go back and read the question, it'll say that drug Z causes drug Y, I think this is drug Y, to be displaced from its plasma protein binding site, which means there's an increase in fraction unbound. Does that make sense to you?
Yes.
Okay. So, and we have these little graphs. I call them graphs, which I think threw everybody off, but these things that say, okay, here's where drug Z is added. So what we know happens
Are
is,
you sharing your screen? Because I don't see
oh,
it.
I am supposed to be. I meant to. How
It's
do I share? Wait a minute.
look at all the footballs. Okay, the fraction was increasing. What is the question again? Where did it go? What are you? This is my ash. Okay. Let's see, displaces.
Is that working now? Can you see it now?
Um,
No.
no.
How about now?
Oh, you know what? It was in the other tab. I see it now. Okay.
Okay, good. So here's our fraction unbound. What we know is when drug Z is added, our fraction unbound increases. So it went from this level up to this level. You follow me? What do we know about enzyme activity or enzyme intrinsic clearance? As far as we know, that's just remaining the same. So these are both given to you in the problem.
Okay.
All right. Then what we want to know is what's going to happen to clearance. Well, how do we determine clearance? Well, we know it's cleared by the liver. We know that much. And then when we get to drugs cleared by the liver, we want to separate them into two groups, if possible, to make it easier to deal with. We want to know if they're low extraction drugs or high extraction drugs.
Okay, I remember that.
Okay?
Yes.
So how do we determine that? Well, you were given that when taking 150 milligrams for the dose IV, that the area under the curve that we got from that was 185. I think that's what I wrote down.
Um,
Yeah, 185
yes,
milligrams per liter times hours, right?
yes.
So what you need to know is that the area under the curve, under curve, I don't know why I did a G, I was making August, I guess, is dose IV over area under the curve, or over clearance. I'm sorry, clearance. So we can calculate clearance, can't we? Because we know the area of the curve is 185 milligrams per liter times hours, and the dose is 150 milligrams. So what's our clearance?
Give me 1 second. Can I do the calculation?
Absolutely, please do. I'm going to do it with you.
Okay. That is the clearance times x on both sides. 150 divided by 185. I have 0.811.
Very good. That's what I got. What are the units on that, Jordan?
That would be so it's what we're looking for, the clearance. What's the area, what's the units of the clearance? If it's I don't remember.
All right. Well, let's see. If area of the curve is milligrams per liter, and what did you do? You actually put that down here. So and this is in milligrams, so those milligrams will cancel out, won't they? And we
Yes,
have actually liters per hour. Does that make sense?
yes. See, that's
Yes,
my
it
problem
does.
too. Sometimes I forget the units because I'm just doing the calculations with the number.
Right. And the
Okay.
units, sometimes, the units work just like Algebra 2, and you got to make sure that they come out right, or it can clue you that you made an error. So I really am trying to be very consistent about writing my units down because I can find mistakes if my units don't work out right. But the fact that it's in a volume per time, we know that's a clearance thing. So the clearance is 0.81 liters per hour. Now, does that help us decide if it's a high or low extraction drug? Yes, it does. But we can calculate the actual extraction ratio because we know that clearance is equal to Q times E, right?
Yep.
And our
It's the
clearance,
clearance, and the clearance cannot be higher than Q.
right, very good. Our clearance in this case is 8.81 liters per hour. And a normal Q is 90 liters per hour, isn't it? So we can solve for E. You gonna do that math for me?
Sure. I love that part.
Yeah, you're good at math. Good. Some people are afraid of it for some reason, which I don't think is a good thing.
That's because everybody always have questions. What I learned with math is I never ask questions. I just do. It can get confusing. Oh wait, 9 times E. Hold on.
We're gonna solve for E.
You by yourself, so you divide it by, so it's 0.81 divided by, I have 0.009.
Very good. That's it. So do you think remember, E goes between 0 and 1. Is this a high extraction or a low extraction drug?
Uh, Hold on. Sorry, I have to think.
Is
Um,
it closer to 0 or closer to 1, Jordan?
it's closer to E is closer to 0.
Yeah, it's almost 0, isn't it? So it's a low extraction drug. You've just determined that it's a low low extraction drug.
It's not as hard as I'm making it.
No, it's not. So, and then once we know it's a low extraction drug, we know clearance is dependent upon enzyme activity and binding. Okay?
Can you say that one more time?
Yeah. Because it's a low extraction drug, clearance, which is what we're trying to figure out, is dependent upon enzyme activity and fraction unbound.
Okay.
So if there's an increase in the fraction unbound, Jordan, what's going to happen to our clearance?
Um, what I want to
If
say,
if our fraction unbound increases, if this increases, what's going
then
to happen to our clearance?
it's going to increase because
That's right.
it says it in the question too. So okay, kind of. I kind of understand it.
Okay. Clearance is going to increase, right? I think the next thing asks what's going to happen to CSS total. So what's going to happen to our total concentration at steady state? Well, what determines that?
F is it F times? Hold on, thanks, Jordan.
You got it.
Dose rate times F divided by clearance.
Yes.
Okay.
Now, we don't need to worry about bioavailability because we're giving it as an IV infusion.
Okay.
So our bioavailability is going to be 1.
One, right, because is that because it's not going through the gut and it's not going
That's
through the,
right. That's
right?
exactly right.
Oh,
And you just told me what's happening with the clearance.
it's going up. So because it's on the denominator, is that the denominator? The
Yeah,
denominator, that means that the CSS will go down, right?
you got it, girl.
I try and tell Dr. Shepherd, I said, I got it. It's just that I need time. I have to function my brain together. Like I've been putting the
I
hours
don't
in.
know. You're plowing along pretty good here. So clearance went up, CSS total went down. Now, the last thing it's asked you about is CSS free.
CSS rate.
And what's the difference between total and free?
Something about it, Roman, the drug Roman free, and I don't know.
Yeah. If it total is drug that's bound to protein and drug that's free from protein, right? So total drug is going to have both bound and free drug. Okay. So if the, what's the difference between total and free?
So total has obviously both of the both bound and free drug, but the with the free is
That's right.
drug.
So Jordan, if I told you that the total concentration of a drug was 100 milligrams per liter and 10% of it was free, what would be the free concentration?
That would that be the unbound?
Yeah, what would the number be?
90?
What would be the if
Oh, the number
if
of the 100.
if 10% of it was free, what would be the free concentration?
If 10% was free, would it be 10 milligrams per?
10. Yeah. So what did you do? So to get CSS free, you in your brain, you did this without thinking. You said total times the fraction unbound, right?
Okay.
Total is 100, and this is 10%, so this is going to be 10, right?
Okay.
You see
Yeah,
that?
because it's only 10%. It's only 100, so that's easy to
Yeah,
determine.
it's easy
Okay.
math, but do you believe me then that this is the truth? CSS free will be equal to CSS total times fraction unbound. Do you believe that equation?
Yes.
Okay, good. So, what is the only difference between total and free then?
Just, I guess, the fraction unbound.
That's right. So the only time we have to look at the free concentration to see what's happening is when there's a change in binding. If it stays constant, we don't have to worry about looking at free concentration. So total will always reflect what's happening with free as long as there's no change in plasma protein binding. Okay?
Because what
But
if,
what happened here? Uh-oh, what happened here?
oh, and it went up and
Yeah,
increased?
there was a change in plasma protein binding. So we need to figure out what happened with free next. So CSS free is going to be total, and you already told me total is bioavailable dose rate, but we're not going to worry about bioavailability because we're giving it IV over clearance, which for this drug is intrinsic clearance times fraction unbound, isn't it?
Okay.
And we know this increases, so our CSS total goes down. But if we multiply this then by fraction unbound, which I can't do because it's making, it doesn't like it. I've run off the page. Can I move it?
If you could put it on the bottom of it, we'll understand. Oh, there we go.
Ooh, fancy. So the fraction unbound has increased. So look, those two cancel, don't they?
Well, so what does that mean? Would that mean the CSS stays the same?
Yeah. So our total goes down, but our CSS average stays the same. That's tricky, isn't it?
Yes.
Because what are we going to read in the lab? The lab will come back with a total concentration, and the lab? It's going to look like the concentration went down because it did. Oops, I don't know how I did that, but it's going to go down. So what do you think the team's going to want to do? What are the doctors going to want to do?
Is it
Increase the dose, aren't they?
let's increase the dose? Oh,
But should we? No, because the free is the active, and at steady state, there's going to be no change in the free concentration.
okay.
So we're going to say no change in dose rate. Blow your mind.
Okay, so the last part, I'm a little confused. So, because it stayed the same, we don't need to change the dose rate. Because
Right,
I
because the free concentration is the active concentration, right? If it's bound, it can't interact with the pharmacologic site. So the free concentration is really what we're concerned about.
okay.
Does
Okay.
that help?
Yeah, it helps. And it does help that to know that if this goes down and this goes up, but if this goes down, but that kind of confuses me also because like I'm that means I'm going to memorize just that. I
Don't
don't
memorize, write it out like I just did.
I mean, yeah, I want to do that, but I want to understand it so when it comes,
Yeah,
I know step by step so I won't confuse when I
right.
won't get confused when I take the test. So
Just do step by step like I just did.
okay. So what is there any cases what's the HEPA clearance workshop or just HEPA clearance in general? Is there are there any chances where well any times where we do change the dose rate?
Yeah,
Is it an example on do we have time for another example? I don't know.
sure, sure. Well, the next one I think is this same drug, so it's still a low extraction drug, but this time I think it's a there's a change in intrinsic clearance. I don't remember if it's increased or decreased. It doesn't really matter. Um, so we still have a low extraction drug.
Which number are you on? The second one?
I think it's the second one.
A drug M inhibits the
Can you
metabolism.
read it?
Yes, decreases clearance.
Decrease in intrinsic clearance?
Yes.
Okay. So what's happening here, instead of an increase in fraction unbound, we have a decrease in intrinsic clearance. Okay. So that's going to change this and this and this and this. I don't know how I get rid of that thing. And this. I don't know, maybe it won't let me. Oh well. We can work around it.
It's okay.
Um, Oopsie. How do I get rid of that now? You know what? I'm just going to start over. Okay. How do I get my pen back? Hmm. There we go. Okay. So what's happened here is it an increase in intrinsic clearance? I don't remember. What does it say for the second question, Jordan?
Uh, hold on, I'm sorry. I gotta find. I just have a but. I always it's like I save it and then it disappears. Where is it?
Too many things.
Okay, here we go. Of what happens to drug Y when drug M is added?
What does drug M do?
Drug M inhibits the metabolism.
Okay, so it decreases intrinsic clearance. So drug M is coming along, and as far as we know, what's happened to fraction unbound? As far as we know, that stayed the same.
Same, because it's one, correct?
Oh, no, it's
Oh no, it's
0.12.
okay.
You told me, but it didn't change
Okay.
because I would have had to tell you it changed, right? Intrinsic clearance, I just told you, decreases when drug M is added. See, drug M is added here, and it causes a decrease in intrinsic clearance. Because you were given that because it said that that's what happened. Okay? No or yes?
No, yes.
Okay. Next is what happens to clearance. Well, low extraction drugs that we know this is determined by intrinsic clearance times fraction unbound. So what's going to happen to clearance?
If it's low, it'll go down.
Yep. Why? Because the intrinsic clearance is gone, right?
Yes.
What about total concentration at steady state?
Would it stay the same?
Let's don't guess. You know. You know what determines total concentration at steady state?
Oh,
Bioavailable dose rate over clearance, yeah?
if that goes down. And that goes up then, right? Oh, hold on. That if that goes down, then the CSS total, yeah, it goes up. Okay.
Good.
A little.
And how about CSS free? Well, CSS free, you know, is just total times fraction unbound. But we also know that the only time that there's going to be a difference between total and free is if there's been a binding change, because the only difference between total and free is the fraction unbound, right? Has there been a binding change?
Well, so if something is inhibit, wouldn't that be yes?
No,
The
that's enzymes that are inhibited. That's a separate issue from binding, isn't it?
Yeah, that's where I'm confused. That's where I'm lost.
So enzymes are like little scrubbing bubbles in your liver that are metabolizing little Pac-Men that are metabolizing your drug, right? They've got their thing going on. Then over here, we've got binding proteins that are a total different thing. Binding proteins are just albumin or AAG that's binding the drug up.
That's in the plasma, yeah.
They're
Okay.
just separate issues.
Okay.
See, we have two things here that are separate.
Okay.
They come together to determine clearance, but intrinsic clearance doesn't determine binding, and binding doesn't determine intrinsic clearance.
So if that's decreasing, then the clearance would be doing the same, right? So
If
that
intrinsic clearance is decreasing for a low E drug, yeah, the clearance is decreasing, therefore total will go up. And how about free? Well, free is just the same as total, so bioavailable dose rate over clearance, which for this drug is this, times fraction unbound. Ran out of space again. And these will cancel, but what's happening? This is happening, right? It doesn't have anything to do with binding, so this will still
go up.
increase, won't it? So therefore, either way, we're going to want to decrease our dose rate, aren't we?
Yep. Okay. That makes sense. Okay.
And these graphs are just to show you how they how they all cause each other in a way, right?
Yeah.
What about half-life? Do you want to make a change in dose interval?
Well, if you have to decrease the dope free, oh no.
We're going to have to figure it out, Jordan. Don't guess.
Thank you
You
for
know,
reminding
just
me, don't get.
work it through, girl. All right. So volume, fraction unbound in plasma over fraction unbound in tissue, divided by clearance. And you told me clearance is dependent upon intrinsic clearance times fraction unbound for this drug because it's a low extraction drug. And what's happening here?
Since that's going down, then that's going that means that the half-life goes up. So oh, okay. That's where I get the dosing interval mixed up because half-life was the last thing we learned in physical pharmaceutics. And that was I felt like that was the hardest part. So every time I see half-life, I think
You
about the
freak out a little bit.
yes.
Half-life is your friend, Jordan. Half-life is your friend.
Okay. So the half-life is the one that determines the dosing and
Well, I mean, it's really the peak to trough ratio, which is dependent upon the slope
okay.
of the elimination curve. But you can kind of take a shortcut and look at half-life because your tau is going to follow your half-life. So if your half-life gets longer, you can extend your dosing interval.
Oh,
If your
and
half-life gets shorter, you're going to need to chop your dose, you need to chop it into smaller pieces, so you need to decrease your dose interval.
so okay, so with this in this case, it says we have to increase, right?
Yep.
Now, if it's already 30 hours, how do we determine
Well, we don't know how often this drug is being given, but the
okay.
half-life has gotten longer, so
Oh,
we
so
can
that's all we
extend
have
our
to
dosing
determine.
interval. We may not. I mean, if it's only being given once a day, you're probably not going to give it more than, you're not going to give it every other day because that's harder to keep track of.
Yeah.
But if you're giving it every 12, it'd be nice to give it once a day. It's easier to take, right?
Yeah. But who wants to be poked? Well, it's IV, so it's already.
Poked or taking an extra tablet. None of this stuff do we want.
Yeah, we all want to be healthy, but as long
Yes.
as we have our medications and we're doing it right, that's all that matters.
Yes.
Okay. That was one of the things I was getting mixed up, like the dose rate, the
Mm-hmm.
dosing intervals and half-life. Okay. So now here sometimes I get the formulas mixed up. Where does K take place uh with everything? Because I always get that confused also.
K is clearance over volume.
Okay.
And it's really just the inverse of half-life. Half-life is 0.693 volume over K. See, these are just inverses of each other. And then you just stick this on there because of the natural log.
So back to the previous thing. Since it's K on the bottom, why do we put the clearance with the previous equation that we just did? Why did we replace K? Like, what's the difference? If you understand my question.
Replace K.
Can you go back to the old slide, the
I
previous?
think I erased it. What was it?
It was
Wait a
zero.
minute. I can undo it maybe. Undo, 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 undo. Okay.
It's right there. Oh, the fraction unbound.
That's volume, yeah.
Okay. Oh, okay. It makes sense. It makes sense. Sometimes I get everything so confused. I have to like think it
Well,
through.
that's because you're not practicing enough.
Yeah. Okay. Because
If you practice, it becomes second nature. It's like anything. If you practice it, you're going to feel comfortable. You're going to know what to do next.
I
You
think
know what I mean?
I practice it, but I don't know. Sometimes I don't
Well,
know
if
how
you
to.
if you're not practicing right, you're going to
Right.
probably
Yeah.
practice the
That's
wrong
the
thing.
problem. Like I have to understand
Yep,
where am I looking? Where am I plugging in? What is happening with our
exactly. Yeah, you
patient?
need to know that.
Yeah. So, okay. I get it. I'm not going to say that.
Now you can go and teach your group.
Well, if they say if you can teach it, that means you know it. So maybe I
Absolutely. That's why I like you guys working in workshop groups because you help teach each other. And then that's good for both the teacher and the student, right?
yes. Oh, I'm gonna cry. Thank you so much.
Don't cry. Yay. Tell yourself, woo, I can do this.
Okay, I was doubting myself before this call, so I mean this Zoom meeting. So
Yeah,
thank
you were a little defeated, but I think you can do it. Now you've gotten yourself in a little hole.
now I gotta dig myself out of the hole.
You got to dig yourself out of the hole. But we're here to help you. So are you going to tutoring? Are you getting all the help you can get?
I try when I don't miss focusing on another class, and then I
Yeah. Are
well
you are
one
you
week
working a lot, Jordan?
sometimes, but I'm a mom, so
Oh, you're a mom and you work? Oh, girl.
I'm so used to I know they say that oh you can't do it, but honestly I wouldn't.
I want to see a picture. Do you have one or more babies?
I just have one child.
Let me see a picture of your baby.
Boo, boo, boo. Oh, they went to go pick up the package. I didn't
You
see it.
gotta go get the package. I gotta go get my dog package.
It's actually not my package, it's my neighbor's package, but
Oh, I call my kids the packages sometimes. I'll say to my husband, "Did you get the packages?"
I'm trying to get a good picture with him and not all bundled up because we're always
What's
in.
his name?
His name's Nazem.
Oh my goodness, what a cool name. What does
Thank
that mean?
he's named after his father. I want to say, is it patience in Swahili?
Oh,
I didn't question it. I was just like, okay, whatever. You
I
can.
love it. I
This
just met another woman with a Swahili name and her, oh my gosh, he's beautiful. What is he like, three, two, three?
he's just little. He's actually 6. He's just small.
Six. Okay, I can't see a person next to him, so I couldn't really guess. He's six. Oh, that's a fun age. Is he there?
No, he just went with his father. That's my sister. She
Oh, okay.
just came with me to help because I'm doing this by myself. I
Oh, Jordan.
with my son and I have to be able to travel to do these darn ippies and be able to keep the lights on and
Oh, sweetie, you got too much on your plate.
I always got a lot of dip on my chip. Okay,
Yes.
that's
You
nothing.
let me know what I can do to support you, okay? I'm
Just
gonna
keep teaching me. Like I sometimes I think I have it.
that put some times on my calendar, okay?
Okay, I will meet with you next Thursday and then I will try to I'm gonna I don't well because you guys are switching, I guess I'm gonna stick
Are
with
you
this
gonna, you need to come to the exam review.
Laura or huh?
Well, the exam review.
Yes. When is the
It's
exam?
it's no, I already did it for you guys. We need to
Yeah,
go over
so
your exam.
I went oh I don't know if
Were
I
you
went to
there? Were you there when I did it with the jackhammer in the background and everything?
that was that at 3 o'clock on Monday? Because I clicked something and no
No,
one
it was
here
on Friday, last Friday.
Friday then no,
All right, well, let's spend some time going through your exam.
please. I
Huh?
guess you could stop recording now, I guess, because I know they're
Yes,
not
I'm
supposed to.
sorry. Yeah.
It's okay. I just don't want
Well,
to get in trouble.
it'll just be for you. I'm not giving it to anybody else. So
Okay. No, I was going to like